Okay, this video should be fairly quick. I just want to make sure that everybody has a good understanding of polynomial standard form. It's important for a lot of reasons. It's a mathematical convention, not necessarily a law. So it's a convention because it's something mathematicians have agreed upon that just simply makes their life easier when they're trying to compare two different polynomials. If they're in standard form, it makes it a lot easier to kind of size them up, and certainly makes it easier to combine them, and that's exactly what we're going to be doing next when we add and subtract them. So the typical polynomials you're going to run into generally have just one variable, and that's what we're going to kind of stick with here. So let's write down an example. Okay. Now, you might initially look at this and go, hey, I've got a second degree polynomial. That's the highest degree. And I got 1, 2, 3, 4, 5. I got 6 terms. So it's a 6-term second degree polynomial. And that's just not right. And the reason it's not right is, first of all, we have some like terms. For instance, this x squared and this 2x squared, they can be combined. There's no other terms that have an x squared, but these two are exactly alike. So we'll want to put those together, and in fact, they're going to be the highest degreed, so we want to make sure they are written first. So we want to start from the highest degree. And when you have polynomials like this where you're combining up like terms, you might as well work with the highest degree terms first, because that just saves you another step when you're done. They'll be in the right order when you complete the exercise. And over here you want the lowest. We start with our highest. If I have 1x squared, remember there's an invisible 1, and 2 more x squared, remember just think of the x squared, the variable part, as a thing. So I got one thing and I got 2 more of those things. That makes 3 things. There you go. Now I'm going to look for the next highest term, which is going to be these x terms. Here I've got a positive 2x. I use 2 underlines to keep them separate from the others. I've got positive 2x minus 7x gives me a negative 5x. Again, you can just think of the x as a thing. I've got 2 things and I give away 7 of those things. I'm definitely in the hole 5 of those things. Finally, our constant terms can be combined. And if you're at this point in your mathematical career, you've probably been combining constant terms already as part of equation solving, so this shouldn't be anything new. We've got a negative 3 here, we got a positive 9 here. We're going to combine those together. We'll get a positive 6. So now we have a quadratic because it's a second degree polynomial, trinomial because it has 1, 2, 3 terms, and it's written in standard form. It's written in standard form with the highest degree, next highest degree, lowest degree. And also, just to make sure that we didn't miss this important vocabulary term, this is what's called the leading coefficient. And if it's written in standard form, the leading coefficient will be the first number you see, because the highest degree term will come first. But if it isn't written in standard form, the leading coefficient could be hidden somewhere else in the polynomial. So you can start to see why writing things in standard form makes sense. You want to be able to look at it, and when you say something like, I want to find the leading coefficient, you would expect to be leading the pack, right? Be the first thing you see. If it's written in standard form, that's exactly the case. It'd also be the case that if you're looking for the constant term, it should be at the very end. And then everything else should kind of follow in sequence. So you can kind of make sense out of the polynomial that way. Okay, that should wrap up standard form.